Good afternoon, everyone. I'm very proud to be here. My name is Renaud Lifchitz. I'm coming from Paris, France. And I will do a talk on blockchain applications and blockchain security, because that's a very hot topic currently. So here's the outline of my presentation. So we will start by introducing blockchain and simple concepts. Then we'll talk about blockchain advantages over other technologies. We'll talk about general use case and use case for banking and insurance. Then we will speak about security. We'll see how to choose blockchain technology and how to choose a smart contract programming language. And we'll finish with security best practices. And I hope the demonstration will work, because I've planned a few demonstrations, but I need an internet connection, so I hope this will be reliable at the time. Let me introduce myself first. So I'm a French senior security engineer working for a company which is called Digital Security. My main activities are penetration testing and security audits. And I do a lot of security research and security trainings in France and all around the world. And my significant security studies were about contactless debit cards. You have probably heard about that. GSM geolocation, blockchain, RSA signature, ZigBee, Sigfox, LoRaWAN. I did a presentation on LoRaWAN last September at hardware.io in The Hague, Netherlands. And you can find all my public presentations on Speaker Deck website, where you have the URL here. And I will publish my presentation at the end of the talk on this same website. So you can find the slides and download them. My company is Digital Security. Digital Security was founded nearly 2 years ago. By the Econocom Group, a worldwide company. And we provide advanced security audit consulting support. We were the first to create the CERT UBIC, which is the first European CERT dedicated to IoT security. So we are experts in connected object and connected security. We have a lab in Paris, where we can experiment all kinds of technologies and radio protocol, and we have reversed a lot of radio protocols like Sigfox and LoRaWAN, and we publish our studies in talks like this. So first, start with some simple concepts, like what is blockchain. A blockchain is a global and distributed registry where there is no single point of failure, right? In fact, the registry is duplicated on every node, and as far as there are at least 50% of the nodes with the good registry will stay forever and ever. Okay, so even if a few computers are infected with a virus, are rootkitted, are attacked, there is no problem, because as far as 50% of the nodes are safe, the registry is completely safe, and the transactions are completely secure. So that's the basic principle. Second principle is all transactions will be authenticated and using electronic digital signature, right? So we have secure and reliable transmission of authenticated information. There are lots of use cases and advantages in using blockchain. We will see a few of them a bit later, and it's fully customizable depending on your business case. The main advantages are the scalability. It's very easy to add nodes to your network. You don't have to change the configuration of the other nodes. You can join the network at any time. You can disconnect at any time, and the network still runs. And as far as only one node is running, it will keep the synchronization with offline nodes when they join again. It's completely resilient. That means it's tolerant to various attacks like denial of service, network attacks, applicative attacks, and so on. You have data integrity and authenticity. That means the registry is completely read-only. Once something is written in the registry, you cannot delete it or you cannot modify it again. So it's completely safe. You have immutable data in the registry. It's completely decentralized, so no single point of failure, as we have seen before. And you don't need to have a trusted third party, like in many other systems, like the web with PKI. Okay, so you don't have to trust anybody, anyone on a blockchain. You don't trust anybody, and the trust will be created by the fact you mine blocks. So it will be very easy for an attacker to have the total compute power of half the network to control at least 50% of the nodes in the network. So nobody knows each other, and it creates a trust nevertheless. And the transaction speed is very interesting compared to interbank networks like SWIFT. SWIFT is very old. SWIFT is very expensive and very slow. So you can create the same kind of thing with a blockchain in a few minutes, and it will be completely free and very fast and very reliable. So as a summary, a blockchain is a completely trusted network, even you don't know any node on the network. So that's quite fantastic. No trusted third party again. What's the most interesting in a blockchain? That you can create smart contracts. Smart contracts is the business logic of the blockchain. Smart contracts are automated, safe execution of defined commitments. So usually you have contracts in banking and insurance, and you can implement the contract using a program, using a smart contract, and it will execute automatically on the blockchain when the conditions are reached. So a smart contract is not a contract in the classical way we define it, but only the execution of defined commitments, right? As soon as you publish the contract on the blockchain, it becomes completely read-only, so even the creator of the contract cannot cheat on the contract, I cannot modify it after. So it's completely trustful. You have a tamper-proof execution because the contract will be executed on every node of the blockchain, and the nodes will vote on the final execution result of the contract. So as far as there are at least 50% of the nodes that are not corrupted, you are sure that the contract will execute trustfully, and nobody can change the result of the contract. So that's very interesting. You have a wide range of possible contracts, many things to do with smart contracts. You can basically implement whatever you want, because it's in advanced blockchain, it's completely Turing complete, so you can program everything you want. You are not limited by the language. You can do multi-party contracts. If you need digital signatures from many people to do something, it's possible with a smart contract. And once you have a smart contract and a web interface, this is called a DApp. Okay, so a DApp is a smart contract and a web interface, so users can easily interact with the smart contract using only a web browser and no difficult installation on their computer. So if you want to find some example of DApps, you have a public directory, which is dapps.ethercast.com. You have hundreds of example DApps. Most are gambling and betting games at the moment, but there are most interesting ones also. More interesting ones, sorry. Let's see now what is an oracle. An oracle is not a database, okay, in that case. An oracle is a small program that will act as a gateway between a blockchain and the real world, which is very often the web. So an oracle will be able to do queries on the internet and return the results to a smart contract. And the smart contracts will be able to act depending on the result of the query. So you can easily bind a smart contract with, for example, the weather condition, with a stock market price, with the news, with an account balance, for example. Right? So an oracle is basically a callable function from a smart contract. One of the most promising blockchain nowadays is Ethereum. Ethereum has nearly 2 years. Transactions are not validated one by one, but are validated by blocks. And blocks happen every 15 seconds on average. So if you do a lot of transactions, they will be packed by blocks. And they will validated all of them. They will be validated every 15 seconds. Ethereum has very powerful smart contracts, unlike Bitcoin, because with Bitcoin you will be very limited with smart contracts. You can only have a small kind of use cases. With Ethereum, you have a full Turing complete language, so you can program everything you want. And they have a mature Oracle system, which is called Oracleize. Oracleize does the Oracle for you. And it's even a provably honest Oracle. And you can prove that the Oracle hasn't changed the results by giving them back to you. By using TLS, Oracleize keeps the TLS injector from the HTTPS requests, for instance. And you can check later that the Oracle was indeed honest and didn't change the results of the query. So that's very interesting too. Ethereum has an excellent community support and very rich documentation. And most useful smart contracts currently are being built with Ethereum. The main programming language for smart contracts in Ethereum is Solidity, which is strongly typed JavaScript variants. So a lot of people know JavaScript and Node.js, for instance, so it's quite easy for them to use Ethereum and Solidity, of course. Let's talk about blockchain use case, so a bit more practical things now. So first, why a blockchain? Why do you use a blockchain, or why you shouldn't use it everywhere? Because blockchain is a buzzword nowadays, and everything is talking about blockchain, and once is project done with a blockchain, this is not a good idea. Blockchain is for specific use, not for everything. So there is some constraints, like you have a limited size and number of transactions per second. Okay, so with Bitcoin you can do about 5 transactions by second. So if you want to do voting, for example, a countrywide voting, it won't complete before several years, because you can only count 5 votes by second. Okay, so it's not suitable for any application. With Ethereum, it's a bit more, but it's more or less the same kind of number. And you have an energy cost because you need to run several computers at the same time for your nodes. It's more energy consuming than one or two single computers, a spare computer, for example. The key factors of choice, if you want to run a blockchain, is if you have a lack of confidence between users, so that's a good condition. If you have concurrent writing by independent users on a registry or database. If you have benefits for user, this will encourage them to use a decentralized system. And if you need disintermediation, if you have many companies doing many things in serial, you can use disintermediation and do something global with a decentralized system. So to summarize, the general use case nowadays are banking, insurance, notary, electronic voting, crowdfunding, as we'll see a bit later with an example, and conditional execution of transactions that we call smart contracts, as you have understood. Right? So general use case, now why do fintech use blockchains for their needs? According to a study, more than 50% of the benefits of blockchain for fintech are based on the creation of new business, new opportunities, new business, and the costs and efficiency compared to traditional way to do it. Okay? So these are the main benefits for fintech. An example of a general use case. With the blockchain, you can do a notary. You can do data anchoring. That is to say, you can put a file or the hash of a file on the blockchain to prove to its existence and that you had this document before at a given date and time. So first you calculate the hash of your file, and then you put the hash in a text field on the blockchain, and later you will be able to prove that at this time you had this document because the hash will match your document. That's exactly what does Wallet, which is a French company who does data anchoring on the blockchain, and they provide a free service that you can use to prove that you had a given document. I should switch my screen to show you first here. No, still no. Okay, doesn't work. There. Right. Yeah. Right. Right, I don't see mine. Right. I will switch completely. That will be easier. You. Right. Easier. So first we log in on Wallet website. And you see you can easily drop a file. Sorry. Drop a file here in order to get its hash and signed on the blockchain. So we'll find one here. That one, for instance. It will compute the hash of the file. And you will have the ability to anchor the file, right? So the anchor has been created here. And I will be able to add tags and metadata, for instance. Any kind of metadata you want, any text you want. And in a few hours, it will be anchored with a lot of other files from all other customers. And you will have a proof of deposit that you can download and give to anybody you have to talk to. So for example, we can download the receipt here of a previous file, and you have a receipt in JSON with the full signature and hash of the file. So I have proved here that we were the first company to offer a security label for connected objects. This was in last December. Right. So this is Wallet, a French company. Okay, no. We've lost the screen. Okay. All right. Much easier. So for banks, now, the use cases are mainly doing international money transfers. And that's the main reason they use blockchain. Because as we have seen, SWIFT, for instance, is very old, is not that secure, and it's quite slow, and it's quite expensive. So banks are trying to replace those kind of network with their own blockchain to do faster international money transfers. That's the case, for instance, of the feeder bank in Germany. They are using the Ripple blockchain to do international money transfer. A lot of other fintech companies have started experiments with the blockchain. That's the case with AXA, for instance, or BNP. And they, all their experiments about blockchain, they post it on Twitter, so you can follow their different experiments. They are publicly disclosing what they are doing with blockchain. Visa is also trying some experiments with the blockchain, not to be abandoned for other technologies, right? And a few other banks example in this table. So this table is given as a reference, so you will find it in my slides at the end of the talk. But you have different kind of experiments with different kinds of advantages that have been found by banks by using blockchain. According to a survey, nearly 100 billions of dollars can be created by this market for banks. So it's a very huge market. I plan to do a demonstration about a smart contract and a deposit. But unfortunately, the testnet was attacked several weeks ago, so it's very, very slow now. So I had the opportunity to do it on the mainnet, the main network of the Ethereum blockchain. But there is some risk with the money, so I won't be able to do a live demonstration of the testnet. It's actually spammed and currently spammed by attackers. So I can only show you what looks like a smart contract. I found the screen. I'm still not able to find the screen, okay. Let's switch. It's working. Hi, yes. So here is an example of a smart contract. So you can see you have the version of Solidity. You can import some libraries from other smart contract or other source files. And a smart contract is actually a class. So you can use class programming, object programming in your smart contract with typed variables. And what the smart contract does is it accepts deposits. And once you deposit something, you have to wait a given time, and then you can cash out your deposit with an interest rate. Okay, so the contracts controls all that things, that you have put a minimum deposit, that you have to wait on to cash out, and it calculates the interest rate automatically. And the interest rate can be gathered using an oracle. For example, the interest rate can be gathered on an official website to be sure that the contract, the smart contract, complies with the law. So you have all the things to do some kind of automatic deposit and cash out using interest rates here, with an oracle and a conversion between euros and ethers, which is the currency of the Ethereum network, the default currency. It's quite easy to have something powerful here. And it starts again and again. Not bad. So for banks, another use case, very interesting use case. Bad screen, okay. Feel a bit complicated to have the correct screen on that one. No. Sorry for that. I don't understand why the screen is so... No? No, I have problem with the screen switching. Sorry for that. No, I have demos, so I cannot switch the laptop. No. Wrong screen again. No, I don't want to duplicate it. I want to have the two different screens, but
okay.
It doesn't work anymore. No, completely. Right. I will duplicate the display then. Sorry for that. Yeah, another interesting use case for banks is the use of tokens. So you can do token management very easily with a blockchain. A token is a custom unit of value for which you want to control issuance, use, and conversion. So, for example, you can have your own electronic currency. You can make your own electronic currency without creating another blockchain. And you can use the Ethereum blockchain and create any kind of electronic currency you want. Any kind of loyalty points you want for retail, any kind of purchase vouchers and coupons, or any kind of proof of tickets you want using tokens. And there is a standard for that, which is called ERP20. So using ERP20, you are able to issue any kind of coupon, any kind of electronic currency, which is very convenient for retail and banks. So let's talk now about insurance use cases. So you can do a lot of things with blockchain, like automatic payment of premiums, automatic computation of risk by oracles and smart contracts, unique loss declaration by users, claim management also by users, and easy payment of compensations. All that kind of thing can be automated using a smart contract, which checks that you have declared your loss, which you have the correct premium, and which check that you didn't had your compensation before. Some use case by the industry. So this is given as a reference, so you will find it in the slides for your reference. And some examples now. Probably the most interesting example that is running nowadays is Flight Delay Sucks, which is a website and a smart contract, so that we call that a D-ape. If you want to be sure that your plane is at time, and on the contrary, if your plane is not at time, you will be paid by the smart contract. You will be given money. You will have a compensation for your flights, and you can create your own policy with the smart contract. So I will show you just after how to create your own policy for flight delays. It's very fun and very easy, and you can even win money if your plane is late. You have another kind of smart contract for drugs and food. If you have a culture like coffee, and the weather is too hot, or you have a lot of flood, and everything is ruined, you can have a compensation for that. It's the same company, Etaris, which does that kind of insurance. Another kind of insurance is social insurance. So it's currently in beta testing, but you can join a group of people that pay a premium, and when someone is ill, will be given a compensation to pay for his medication or to stop working for a few days. It's currently being tested, but probably this will get bigger and bigger, and you will have a completely decentralized social insurance that can be very useful in some countries. Allianz does some experiments about natural disasters, and AXA does also some experiments about sidechain developments. So a sidechain is a blockchain that is linked to the main blockchain, but which contains sensitive information. You know, there are some regulation about banks and insurance. They cannot put personal information on a public blockchain. They cannot put names of customers. They cannot put balance in a public blockchain. So they put all that kind of confidential information on a sidechain, which is a private blockchain, and they link this information to the main blockchain to have a proof, that is to say, a kind of hash of their confidential information, and have a complete trace of all their operation without confidential information publicly available. So, well, an interesting example is, as we have seen, an insurance about flight delays. So this is flight delay sucks. To use it, you just have to install some kind of extension here, which is called MetaMask. MetaMask will do the link between your browser and the blockchain. In that case, it is the Ethereum blockchain. So you install the MetaMask plugin in your browser, and now you are able to browse the websites and be connected to the Ethereum blockchain at the same time. It's very easy to use. So you can see here we are connected to the blockchain. You have the address of the contract, the address of my accounts, my funds in the account. So let's assume that I want to take an insurance for my next flight between Paris. So I choose the departure airports and the arrival airport, which will be, for example, San Francisco, right? And I will do my trip next Monday. So next Monday will be the 6th, right? I'm looking for flights between Paris and San Francisco for next Monday. So I click on search. And then I'm able to choose a few flights. So let's assume that my flight is the first one. Okay? So now I have all the probabilities that my flight will be late according to the previous records. So I can see that my plane will be late between 15 and 29 minutes with 4% probability. That it will be late between 30 and 44 minutes with a 16% probability, and so on. And if I want to have a compensation if my plane is late, I have to pay a premium, but I can choose my premium. I can choose, for example, to pay 5 Ether as a premium. The Ether nowadays currently costs $20. So here I pay a premium of $100 for my flight, but I can choose exactly the premium I want to pay. And when I type the amount of the compensations are automatically computed. So now I see that if I pay 5, I will be given 8.5 if my flight is between 15 and 20 minutes late. And if I agree with that, I click on apply. If the internet connection works. Yeah. I accept the transaction. Give me the cost of the transaction. So it's nearly $100 here. And I have the hash of the transaction, that is to say, the complete reference to the blockchain transaction, which is written forever in the blockchain. It's here. Right. So once the transaction gets confirmed, it will appear in my account, and I can see that my policy has been recorded forever in the blockchain, and the smart contract will be able to check regularly that if my plane is late, and as soon as my plane is late, I will be paid. So there is no company involved, no insurance company involved. It's completely automatic, and it's completely managed by a smart contract, which is to say a program. So the program will collect the premium, will take a fee, and I will get my compensation in case the plane is late completely automatically. And nobody can cheat on that system. Nobody can change the contract. Nobody can cheat on the results, because it's automatically checked and enforced by an oracle and probably honest transaction. So that's the interesting case. So let's finish with blockchain security now, which is an interesting topic. The question will be at the end, please. So let's talk about the DAO case. Perhaps you have heard of the DAO case. The DAO was a crowdfunding smart contract developed by Lifchitz, a company which develops electronic locks connected to the blockchain. So they created a smart contract to do all the crowdfunding automatically. A DAO is a decentralized autonomous organization, that is to say, a kind of organization that is completely standalone, right? And more than $150 million were collected. That is 15% of all Ethers at this time, a lot more than required for the crowdfunding of the project. So a lot of money were collected by this smart contract, a lot of success for this smart contract. Everybody was enthusiastic. But unfortunately, on June last year, there was a robbery of 1/3 of the funds because someone has found a vulnerability on the smart contract implementation, not on the blockchain. The vulnerability was not on the blockchain or on Ethereum, but on the smart contract implementation. In the smart contract program, there was a vulnerability allowing somebody to do recursive calls of the withdraw function of the smart contract. So the attacker was able to withdraw in continuous the same amount of money again and again, and withdraw nearly 1/3 of the funds that were deposited. A hard fork by the Ethereum community was needed to modify the contract and to save the funds, so they changed the blockchain in order to blacklist specifically the smart contract and save the fund and give the fund back to all the investors. Right? So this is an important governance question. Is the governance made by the investors, by the developers, by people who fund the project? That's an interesting question, which arises in all kinds of blockchains. That's an interesting problem. If somebody uses a vulnerability in a smart contract, is this a feature of the smart contract? That's the question. So there were a lot of interesting questions that are still not solved, but blockchains ask a lot of governance questions in order to decide and to choose who will be able to change the blockchain if something arrives. So let's talk about how to choose the blockchain technology. There are important criteria like maturity, security, for instance, interoperability, the support for oracles and sidechains, the smart contract possibilities, that is to say if it is Turing complete or not, and the scaling of the network, the max size of the transaction and the delay between blocks. Because the less the delay is, the less security you have. But the less time you have to wait between transactions. The transactions are very fast, but you have less security if you have to wait less time, because they don't have enough time to get confirmed by a lot of nodes, right? For instance, some kind of very well-known blockchain. So you have Bitcoin, which is the most famous one, which has nearly 6 years, I think. Ethereum 2 years ago, which is more complete for business use case. Ripple, which is used by a lot of banks, which is a semi-private blockchain. You cannot connect your own verifier on the blockchain. You can only connect a node that is reading the transaction, and you cannot write anything without the authorization of the foundation, because Ripple is a foundation. You have Byteball, which is quite recent, and Byteball is interesting also. It's not a blockchain, but it's an electronic currency with an electronic network, and everything is stored in a direct acyclic graph, DAG. So every transactions get confirmed by itself. There is no need to wait for a given time or a given block to get all the transactions validated. Every transaction will be validated one by one, and they use no blockchain. And they provide also anonymous support. You can do anonymous transactions, anonymous transfer of funds between two people, and they will be transfer off-chain. So no clue that there was an anonymous transfer between two accounts. So that's quite interesting. You have others like Lisk, which embed the web interface in the smart contract. So everything is stored in the blockchain, even the web interface for your DApp. And you have also Tezos, which works with a functional language to have a proof of security. Now, how can you choose your smart contract programming language? Basically, there are two kinds of languages. You can use imperative languages, like JavaScript, as you have seen in Ethereum, which is common, easier to write, but very complex to verify using formal proofs. With imperative language, it's nearly impossible to use formal proofs to check that your smart contract is correct and is safe. On the other hand, you can use functional languages. With functional languages, it's a bit complex to program. It's a bit unusual to developers all around the world, but it's quite easy to verify using formal proof because there is no side effects in any function. So you can modelize with math. All is done using this. All what is done is using the smart contract, and you can basically prove that your smart contract does everything you want and not other things. What are the best functional best practices for using the blockchain? First, you have to make things simple, make your smart contract very simple, very modular, and use as soon as possible, as often as possible, the code from other people that has been double-checked for security issues. You have to do unit and integration testing. And you have to use economic incentives. That's very new to smart contracts. That's not the case in classical programming. You have to limit the amounts you collect, using, for example, in crowdfunding smart contracts. You have to propose bug bounties, not for your smart contract to be hacked. It's better to give money to people if they find vulnerabilities than that your smart contract is being exploited and that your investor money being stolen, right? And you can even use what is very new, prediction markets. So prediction market is a kind of market where you can make bets on news, but it's more a predictive market, like is this smart contract safe, will it rain tomorrow, and so on, and you can bet and win money if you have the right assertion about a given fact. So you can use also a prediction market to check if your contract is safe enough without it being hacked. And another best practice is to separate the condition and actions in your code, which is called the condition-oriented programming. The best technical best practices now. A good idea would be to implement a kill switch in your smart contract. In that case, if your contract is being attacked, you are able to disable all kind of cash outs. It's a kind of panic button where you can lock the fund if something appears, and you will be able to cash out manually and give the fund back to your investors. So that's a good practice to do in your smart contract. to avoid being hacked. You can use pre and post conditions in the functions to check that every parameter is good, every kind of result is good. You can use formal proofs, as we have seen. You can use mocks in your tests. And the best is to use test environments for developing your smart contract. There is a lot of frameworks and testnet you can use. So read the fucking manual. And to finish, my company, Digital Security, is offering a lot of blockchain services. So feel free to ask if you have projects. We have a blockchain solution. We provide technical and legal risk analysis. We provide smart contracts audits and cryptography audits, and we will be able to advise you for your needs. Thank you, everybody. So you have my email contact if you want. You can follow us on Twitter at IoTCert. And my Twitter is Nono2357, Nono2357. Thank you. If you have questions, I will be happy to answer, or I will stay in the hotel for today. Today is more, so feel free to ask me anytime.
Hi, thanks for the talk. What happened in the flight insurance service if you invest money and it happens that you're the pilot of the plane and you decide to be late?
You can cheat with this kind of insurance. You can cheat, but it's a bet. So if you can influence the bet, you can win, of course. But that's part of the risk. I mean, you can go on the plane with a bomb. It will delay the plane for sure. But you will have problems for sure also. Another question here?
Regarding oracles, I saw in your example that external code is called, like code stored on GitHub, and they also go to the internet to check for example, rates. All of these things can be manipulated from the network. So how can we be sure that the code is correct and everything which is called from the outside is correct too?
That's a good question, but actually the compilers takes all things at compilation time. So only the compiled contract will be stored in the blockchain with no external dependency. So it's made at compilation time. Everything is compiled in bytecode, and only the bytecode is stored on the blockchain and will be executed by the virtual machine.
Okay, that's for the code aspect, and for the data aspect, which is going to the internet to grab like exchange rate.
And for the data aspect, we have seen that the only way to make requests to the internet is using an oracle. And the oracle is probably sure, because it keeps, if you do an HTTPS request, it keeps the TLS signature, and you can check it back when you have the result. You can check that the signature is correct, so the data wasn't altered by the oracle.
Okay,
so
I have more questions.
It's a probably safe oracle. That's an interesting thing.
Okay, thanks.
Thank you. Thank you, everybody, for your attention.